problems out of 2.1, and now the mathematics you need for it. So tomorrow, when I give an introduction to calculus, one of the key concepts what we do is called the derivative of a function, or the ability to compute the slope of a tangent line to a graph of a function. So if we look at a function f, we look at the graph of the function f, we take an x value a, and then we get an output of f of a. And I ask you, by how much does the function change in a neighborhood of a? Then you will look how steep the curve is. The steeper the curve, the more change the function will have. The change in the output is related to how steep the curve is. Now the second curve, if I change a, the output does not change. Stays the same because I have a horizontal line. So the change of the output is 0. In the first curve, if I change a, then the output will change a lot because the curve is steep. Yeah? You have a slope. So the problem is we have to compute the slope of the curve at a certain point. Now the problem is, to compute the slope, you need 2 points. The slope of a line is delta y over delta x. Yeah, in order to compute a slope of something, you need 2 points. But we have only 1 point. So to compute the slope of this line, you take now another point, I call it x. And I pick this x now really close to a. I just cannot do it. If I pick it too close to a, you don't see it in my picture anymore. So this is a screwed up picture. It's a bad picture. Yeah? I should put the x much closer to a than I did here. It's just that you see it. I put it a little bit farther away. In principle, I want to take an x as close as possible to a. And now I have 2 points, and I can look at the slope of this secant line. In the slope of the secant line is delta y over delta x, rise over 1, where the rise is this piece here, that is f of x minus f at a, and the run is this piece here, this is x minus a. And if x is really close to a, then this number will be a good estimate of the slope of the tangent line to the curve at this point. So the slope of the tangent line will then be we take an x very, very close to a. This is what this limit means. So a limit means you take x and a number x that is not equal to a, but very, very close to a. So the limit means it's a process. Take inputs x that are closer and closer and closer to a, and see what happens with the numbers f of x minus f of a over x minus a. And that's the two homework problems what you should look at. Huh? It's basically a calculator problem where you have to plug in numbers in calculators and come up with numbers. Okay, so that concludes the lecture today. Tomorrow I do nothing but going over this picture again, explaining this, and go then cover 2.1 and go to 2.2.